There is a 250 gram sample of liquid water at 20 degrees Celsius in a styrofoam cup. A 30 gram sample of copper at 90 degrees Celsius is dropped into the water. What will be the final temperature of the water in the copper, assuming no heat is lost to the styrofoam cup? Let's start by listing the information provided. We have 250 grams of liquid water at 20 degrees Celsius with a specific heat capacity of 4.18 joules per gram degree Celsius, which we found from the table. We also have 30 grams of copper metal at 90 degrees Celsius with a specific heat capacity of 0.385 joules per gram degree Celsius. Next, the question prompts us to solve for the final temperature of both the water and the copper, which we will call capital T subscript F. We can use the equation negative Q of copper equals Q of water to solve for T final. Q represents heat, where Q of copper is negative because the warmer copper loses heat to the cooler water. Q is found by using the equation Q equals the mass of the substance times the change in temperature of the substance times the specific heat of the substance. The change in temperature, or delta T, equals final temperature minus initial temperature. Using orange for copper and blue for water, we can set up our equation to find T final as follows. Negative mass of copper times specific heat capacity of copper times delta T of copper equals mass of water times specific heat capacity of water times delta T of water. Before plugging the numbers in, we can simplify to an equation for T final. Using basic algebra, we can solve for the unknown variable T final. Eventually, all the units cancel out except for degrees Celsius. We end up with an answer of T final is equal to 20.8 degrees Celsius. Thus, using the information provided and the concept that the water gains all of the heat released by the copper, we were able to determine the final temperature of the system.